Welcome to today's research Kazakh. I'm going to hand it over to our speaker for today, Kaleigh Miech. Apologize if I got that wrong.
That's okay. Thank you. Like Lauren said, my name is Kaleigh Miech, and I'm a graduate student at the University of New Hampshire. I am going to be presenting a project today called Determining Asphalt Pavement Milling Best Practices Through Enhanced Understanding of Milling Operations. I have been working on this project in collaboration with Dr. Ishan Dawe and Dr. Joe Sias from the University of New Hampshire, along with Dr. Rajiv Malik from the University of Texas at El Paso. So today in this presentation, I'm going to begin by discussing the project background and objectives, then move into the sampling, testing, and analysis methods, then go into the results of the testing and analysis that we performed, and then discuss the final conclusions and future work. So beginning with the project background and objectives. So as we all know, asphalt pavements are structures of layers, and the strength and the stiffness of the layers decrease with depth. Asphalt pavements can have structural and or functional distresses. And so we use milling commonly in asphalt pavements to remove the topmost layers of asphalt, which is used as a maintenance and rehabilitation method to correct functional distresses and also sometimes structural distresses. Milling is a high stress activity, but even though it's a high stress activity, the damage below the mill line is currently unassumed. So because the damage is currently unassumed, we generally select milling parameters based on cost, routine, and the state of the existing pavement. So the overall objective of this project was to better understand the influence that milling operations and specific milling parameters have on the pavement layer that remains directly below the mill line. So now I'm going to begin discussing the sampling, testing, and analysis methods that we conducted in this project. So like I said, the overall objective was to determine how milling parameters impact the asphalt layer that remains directly below the mill line. So to conduct this study, we collected pre-milling cores, milled the surface of the pavement, then collected post-milling cores. We then transported the cores back to the laboratory and trimmed them to represent the equivalent layer of pavement directly below the mill line. And then we evaluated the pre and post milling cores in the lab for different mechanical and physical properties. We collected all of the cores from the Min-Road Research Facility as well. So we evaluated 5 different milling parameters in this study. The first one was the structure of the existing pavement. So to evaluate this parameter, we collected pre and post milling cores from 3 different pavement structures at the Min-Road facility. The second parameter is the timing between milling and post-mill overlay construction. So we collected pre-milling cores, milled the surface, and then collected post-milling cores directly after milling, 1 week after milling, and 2 weeks after milling. The third parameter is the proximity of the mill line to the asphalt layer interface. So we milled to the layer interface, 2 halfway through the lift, and 2 3/4 of the way through the lift, and collected pre and post milling cores for all 3 depths. And then the fourth parameter is the operational equipment parameters. So we evaluated the rotor speed while milling, the teeth spacing, and also the rotor type to see if any of these parameters impacted the impact that milling has to the remaining HMA. And then lastly, we evaluated the pavement temperature while milling to see if milling while the pavement was at cooler versus warmer temperatures influenced the impact that milling. So like I said, once we collected both the pre and post milling cores, we brought them back to the lab and we trimmed them to represent the equivalent layer directly below the mill line. We then evaluated these cores in the lab for bulk specific gravity and permeability, along with resilient modulus and indirect tensile strength. We were not able to conduct permeability testing on all of the cores because the permeability device that we used only allowed cores with a diameter of 6 inches, but we had some cores that were collected with a diameter of 6 1/4 inches, so those were unable to be evaluated for permeability. Once we did all of the 4 tests on each of the pre and post milling cores, we then calculated the average laboratory measured, the average laboratory measurements for the pre and post milling cores under each parameter. We then use these average values to calculate the percent difference between the pre and post milling cores for each property under each milling parameter. And then lastly, we also did statistical significance testing to determine if there were statistically significant differences between the property values of the pre and post milling cores. The next analysis that we did was a pavement life analysis. So to conduct this analysis, we used the MinPave software, and we determined the expected pavement life of the pavements that had been designed as if they were impacted by milling versus those designed as if they had not been impacted by milling. So we used two different pavement structures, the thin and the thick pavement structure, just to give us a wider range of results to analyze. And the thin one had a smaller amount of lifetime easels, and the thick one had a greater amount of lifetime easels. And so what we did in the MinPave software was we kept all of the property values of all layers the same except for the old HMA layer. And we inputted that one time as the laboratory measured pre-milling resilient modulus. And then we did the same exact life analysis with the old HMA value being the post-milling laboratory measured resilient modulus value to compare the difference in pavement life using the pre-milling and the post-milling value. And we did this, like I said, for both the thick and thin structure. We also had FWD data that was collected on some of the pre and post-milled structures. This data was collected pre-mill and then post-mill pre-overlay to evaluate any impact that milling may or may not have had on the HMA that remained below the mill line. So we used this data to back calculate the stiffness of the layers of each of the pavement structures. And this allowed for comparison of the back calculated HMA modulus values between the pre and post milled structures for each cell. And then we also collected surface modulus data to determine if the milling impacted the overall structural capacity of the pavements as well. So now I'm going to be discussing the results from these testing and analysis methods that we conducted, and beginning with the existing pavement structure. So here are the three different min-road cells that we evaluated for comparison of how the existing pavement structure does or does not influence the impact of milling. So we evaluated three different pavement structures, min-road cells 101, 201, and 2. As you can see in min-road cell 2, the thickness of the remaining HMA was about 2/3 that of the remaining HMA in cells 101 and 201, which we will discuss in further slides. So here we have the results from min-road cell 101. We have the specific gravity, permeability, resilient modulus, and indirect tensile strength, where the dark blue is the pre-milling cores from the driving lane of the cell, light blue is post-milling from the driving lane, and then dark orange is pre-milling from the passing lane, and light orange is post-milling from the passing lane. So by examining these figures, we can see that there was a slight increase in both lanes in the specific gravity of the cores, and there was also an increase in resilient modulus in both lanes, and there was no consistent change to the indirect tensile strength between the pre and post milling cores. Then these are the results for min-road cell 201. Here we see that the specific gravity, resilient modulus, and indirect tensile strength increased more in the passing lane of the cell than it did in the driving lane. And then lastly, for min-road cell 2, we can see that the cell 2 properties, especially for resilient modulus and indirect tensile strength, were substantially smaller than that, were substantially smaller in cell 2 than they were in that of cells 201 and 101. And we can see in these results that the resilient modulus increased in both lanes, while the indirect tensile strength decreased in both lanes. When we did the statistical analysis of these results, we found that milling did not have a statistically significant impact on the specific gravity, resilient modulus, or indirect tensile strength in cells 101 or 201. And we did find that in that post-milling, there was a statistically significant increase to the resilient modulus of the HMA directly below the mill line in the driving lane of cell 2, but not in the passing lane. Thus, there were not consistent significant differences or impacts to the HMA below the mill line for the 3 cells with the different structures. Because there was a statistically significant difference in the resilient modulus of the HMA in cell 2, we conducted the pavement life analysis for the cell. So we found that in the driving lane of cell 2, assuming the thinner pavement structure, due to milling, there was an expected pavement life underestimation of 11%, and in the thick structure of 18%. And then here we have the FWD results for each of these 3 cells. So the OWPD is the driving lane for cell 2, and then OWPP is the passing lane for cell 2. And same for the other 2 cells. So we can see when we examine these results that the post-milling values from cell 2 are unrealistically high values for a back-calculated modulus. This is likely due to the thinness of the HMA layer that remained after milling in cell 2, which I discussed when I showed the cross-sections of these cells. When we examine these results, we can also see that there is an increase in the HMA modulus values from pre to post milling in both lanes of cells 101 and 201 as well. Then these results are the surface modulus results. So when we examine these results, we can see that post milling, the surface modulus decreased in both lanes of cell 101 and 201, but increased in both lanes of cell 2. So we can conclude from this that in cell 2, the results show that milling did not lower the overall structural capacity of the pavement, but in cells 101 and 201, there was a decrease in the capacity of the pavement. Next parameter that we evaluated was the time between milling and post-mill overlay construction. So here I have a schematic of the cross sections of the cells that we used to evaluate this parameter, which was min-road cells 3 and 4. We evaluated, like I discussed at the beginning, 3 different parameter variations: immediately after milling, 1 week after milling, and 2 weeks after milling to simulate post-mill overlay construction. And so obviously the increased amount of time between milling and post-mill overlay construction, there's increased exposure to weather and traffic. Here I have the weather conditions that these cells experienced in the 2 weeks between core collection. So we can see that the temperatures are not in the freezing range, and there was minimal rainfall throughout the 2-week period. These are the results for the evaluation of this parameter. So when we evaluate these results, we can see that there was, the dark blue is the pre-milling collected from cell 3, and then light blue is the post-milling that were collected directly after milling, also from cell 3. Then the dark orange is the pre-milling from min-road cell 4, and then the first light orange are the cells collected 1 week after milling, and the second are those collected 2 weeks after milling. So when we examine these plots, we can see that there was an increase in the resilient modulus and indirect tensile strength for cores collected 1 week after milling, but a decrease in the resilient modulus and indirect tensile strength for the cores collected 2 weeks after milling. The hypothesis for this is that the initial exposure of these milled surfaces may have provided a slight compaction from the initial exposure to traffic may have provided a slight compaction while helping to close some of the micro cracks, whereas the repetitive loading may have eventually degraded it and could have reopened the micro cracks. Also, there was slightly more rain in the second week than there was in the first week, which may have also contributed to this as well. So when we analyzed these results, we found that there was a statistically significant decrease to the specific gravity and the indirect tensile strength of the hot mix asphalt below the mill line when the milled layer was exposed for 2 weeks. But the results did not indicate that there was a statistically significant difference between the pre and post milling cores for those collected directly after or 1 week after milling. Further analysis for the expected pavement life indicated that when leaving a milled pavement exposed for 2 weeks, the expected pavement life did not change when assuming the thinner pavement structure, but was overestimated by 13.3% for the thicker pavement structure. Here we have the FWD results. They were only collected for Min-Road Cell 3 and not Min-Road Cell 4. So Min-Road Cell 3 correlates to the cores collected directly after milling. We can see that the post-milling back-calculated HMA modulus values are also unrealistically high for this cell. So these values are disregarded like in cell 2 because they are likely extremely elevated due to the thinness of the HMA layer that remained after milling, which was only 44 millimeters. For the surface modulus results, we can see that in both lanes, the surface modulus increased post-milling, and there was a greater percent increase in the driving lane than there was in the passing lane. And the overall capacity of the Min-Road Cell 3 did not decrease post-milling, even with the lower HMA thickness. And this Min-Road Cell 3, like I said on the previous slide, this correlates to the cores collected immediately after milling. And so, like I said, even with the lower HMA thickness, the overall capacity of the cell 3 pavement structure did not decrease. And thus, it can be assumed that there was no damage to the cell from the milling activity when when the cores were collected directly after milling. The next parameter is the depth of milling relative to the layer interface. So we milled to 3 different depths. One was to the layer interface, the second was to halfway through the lift, and the third was to 3/4 of the way through the lift, which you can see correlating to lines A, B, and C in the schematic on the right. So for the results for this parameter, the gray is the pre-milling cores, and then the blue correlates to the post-milling cores after milling was performed to the layer interface, the orange when milling was performed to halfway through the lift, and the green when milling was performed to 3/4 of the way through the lift. So when we examine these results, we can see that there was a decrease in the resilient modulus and indirect tensile strength when milling was performed to halfway or 3/4 of the way through the lift. So like I said, for the analysis of these results, the results show a slight decrease in the resilient modulus and indirect tensile strength when milling was performed to halfway and 3/4 of the way through the lift, which is likely caused by a natural weakness that is already occurring at the interface that is not occurring at halfway or 3/4 of the way through the lift. And the results from this study do not indicate that there is a statistically significant impact to the specific gravity, resilient modulus, or indirect tensile strength of the hot mix asphalt below the mill line, regardless of the depth of milling. And then here we have the FWD results for these cells. So as we can see in Min-Road Cell 115, there was a 25.5% increase in the hot mix asphalt modulus post-milling. And in 215, there was an 11.8% decrease in modulus post-milling. Milling was performed to the interface and halfway through the lift in cell 115. It was a split cell used for the 2 different variations. And then in cell 215, it was also a split cell where milling was performed halfway to the lift and also 3/4 of the way through the lift. So in 115, milling was less deep, but when in min road cell 215, it was performed to deeper depths. And so as with the core data, there was a decrease to the modulus of the HMA when it was not performed to the interface. Here we have the surface modulus results for these two cores, for these two min road cells. And we can see that in both cells, the surface modulus decreased post-milling, indicating that the milling activity did lower the structural capacity of the pavement. This may have been damage due to the milling activity or due to reduction in the thickness of the structure as a whole. Next is the operational and equipment parameters. So like I said, we set out to evaluate 3 different operational equipment parameters in this study, which was the rotor speed, the teeth spacing, and the rotor type. Unfortunately, the spacing between teeth and the rotor type were unable to be evaluated in the study, but we did evaluate the rotor speed while milling. So we performed milling at 3 different speeds, 100 RPM, 109 RPM, and 118 RPM, to evaluate if these different speeds impacted the influence that milling had to the HMA remaining below the mill line. So we collected these cores from these 4 different cells, which all had similar structures, but some with different PG grades in their HMA. So because of that, we only compared pre and post milling cores collected directly adjacent to each other. So here we have the results from these cores. So the dark blue correlates to the rotor speed of 100 RPM pre-milling, and then the post-mill is the corresponding post-milling core. And then the dark and light orange are corresponding for pre and post-milling for 109 RPM. And then the dark and light green is the pre and post-milling for 118 RPM. So we can see when we evaluate these results that at the lowest rotor speed, there was the greatest percent increase in resilient modulus. And at the highest rotor speed, there was a decrease in resilient modulus. So like I said, when milling was performed at 100 RPM, there was the greatest percent increase in resilient modulus. And then at 118 RPM, there was a decrease in the resilient modulus. So these results indicate that as the rotor speed increases, the resilient modulus of the post-milling cores decreased relative to the resilient modulus of the pre-milling cores. The percent differences between the specific gravity and the indirect tensile strength that were measured did not display consistent changes as the rotor speed changed. And then lastly, when the statistical testing was performed on the results from these cores, the results did not indicate that there were statistically significant impacts to the properties evaluated of the HMA below the mill line, regardless of the rotor milling speed while milling. And the last parameter that we evaluated was the pavement temperature at the time of milling. So we evaluated pavement temperatures, a cooler pavement temperature where the pavement temperature at the time of milling ranged from 12 degrees Celsius to 15 degrees Celsius. And then we also evaluated it at a warmer pavement temperature, which ranged from 33 to 47 degrees Celsius. So with an increase in pavement temperature, there is a decreased strength and stiffness. And with a decrease in temperature of the asphalt, there is increased strength and stiffness. So when we evaluated this parameter and we did the laboratory testing, we found these are the results that we found. So the gray correlates to pre-milling cores from that are to be compared with the blue, which are post-milling cores when milling was performed at a cooler temperature. And then also the gray is compared with the light orange, which is post-milling cores collected at a warmer temperature. And then the black is pre-milling cores collected from different cells that are to be compared with post-milling cores collected at a warmer temperature, which is the darker orange. So when we evaluate these results, we can see that there is a greater percent decrease in the indirect tensile strength of the asphalt below the mill line when milling was performed to a cooler temperature than when milling was performed to a warmer temperature. When we performed the statistical testing on these results, we found that there was a statistically significant decrease to the indirect tensile strength of the asphalt below the mill line when milling was performed at a cooler temperature. Whereas the results from the study did not indicate that there was a statistically significant difference between the indirect tensile strength of the pre and post milling cores when milling was performed at a warmer temperature. The results from the study further indicated when we conducted the pavement life analysis that when milling was performed at a cooler temperature, assuming the thinner pavement structure, that the expected life of the pavement decreased by 8.3%. And when assuming the thick structure, the expected life decreased by 5%. Now moving on to conclusions. So from the conditions evaluated in this study, it was found that milling while the pavement was at a cooler temperature or leaving a milled pavement exposed for 2 weeks can cause a significant decrease to the strength of the asphalt layer directly below the mill line. From a further analysis, the results showed an expected pavement life decrease of 8.3% when milling at a cooler temperature, assuming a thin structure, and 5% when milling at a cooler temperature, assuming the thicker structure. We also found that the expected pavement life would decrease by 13.3% when leaving the milled pavement exposed for 2 weeks, assuming a thick pavement structure. In addition, we found that adjusting the depth of milling relative to the layer interface or the rotor speed did not display significant impacts to the physical or mechanical properties of the asphalt layer directly below the mill line. And the structure of the existing pavement did not consistently influence the impact of milling to the HMA layer directly below the mill line. Moving on to future work. So this is this project has many future study possibilities to continue on with the research. One is to evaluate additional samples under the same milling parameters that were evaluated in the study to confirm these preliminary outcomes and to determine if there is a need to develop milling parameter guidelines based on the parameters evaluated in this study. In addition, there are many other milling parameters that could be evaluated, such as the milling machine moving speed, the conditions of the milling teeth, or the milling drum diameter. And in addition, there's other aspects of the remaining pavement that could be evaluated, such as how each of the parameters impact the milled surface, or how potentially other deeper layers are impacted by milling. So that's all I have for today. I would like to acknowledge and thank the National Road Research Alliance for their support during this project. In addition, I would like to thank the MnDOT staff members, Emil Bautista and Ben Worrell, as well as Caterpillar for their substantial help in field experimentation and sampling for this project. And thank you very much. And if you have any questions, please let me know.
Thank you, Kaleigh. I do not see any questions in the chat, so we can open it up to people raising their hand and unmuting.
I guess I'll break the silence. This is Ben Worrell.
Thanks, Ben.
Camera actually works. I guess, Ishan, I'd like to hear some of your thoughts on the project and kind of paraphrasing what you think we saw, because what I saw was, you know, we documented things to the nth degree. We had Caterpillar come and really helped us a lot with, playing around with these different variables. And we did a lot of different things and a lot of different test sections. And how could you paraphrase kind of the discussion we had here?
Yeah.
And a nice job in presentation. Thank you very much for that.
Thank you, Ben, for that question. And I think it's really, I mean, first and foremost, I cannot thank enough folks at Caterpillar. I mean, they were tremendously accommodating. As Ben mentioned, this is a prime example of what a facility like Min Road, together with what a partner like Caterpillar can make this happen. I mean, I cannot imagine going to an actual pavement milling site and asking to do even a tenth of what we were able to do here, because as Ben mentioned, I mean, through the literature review, and actually I should actually first and foremost also give credit to Professor Rajib Malik at UT El Paso, because the idea came from him. They had done quite a bit of initial work, and actually recently had a PhD graduate on a similar topic where they've done a lot of simulation and lab testing to show that when you are doing milling, it's such a high energy activity that you could be impacting layer below. So keeping that in mind, we had a lot of information coming from their group, literature review. We were able to identify all these variables that Kaleigh talked about, things like how new or old your pavement is, or whether you cut at the interface or halfway through your lift, what happens when you cut early in the morning when things are cooler versus right in the middle of the day in summer when things are hot, leave it open, things like that. And I think, as Ben mentioned, I mean, with being on Min Road, we were able to actually do a lot of things. We literally had Swiss cheese situation with pavement as well, because we were taking so many cores, and the key was to be able to take cores before the milling machine goes by, and then after it goes by, taking core right next to that first core, so you can really make a true pre and post mill comparisons. And so doing this, I think the bottom line, what we learned is, yes, there are certain situations where the layer below does get impacted. It does get impacted, especially when you have certain temperatures, colder temperatures, you have substantial effect. Other thing that the study did confirm is what a lot of construction people have always been talking about. Actually, a lot of state specs have this in their specs, to not let traffic or leave mill surface open for too long. We saw that it does change. Now, it wasn't really consistent in this example or in this trial, and that's partly because of weather as well. And you have to keep in mind, this is at Min Road, so we're not really open to traffic during construction. So it was mostly environmental with some construction traffic going back and forth. But bottom line, to just like let's say a synopsis version, I think three things came out of this, in my opinion. One, um, for a lot of situations, especially one of the big ones that we had seen in simulations and lab trials, did not really show as big of a concern, where when you are cutting partially through a lift versus at interface, we did not see at least statistically significant impact on the underlying layer, keeping in mind that the pavements were fairly distressed. So we did not really do this on a brand new pavement. The pavement was already had substantial structural damage to it. Second thing is temperature is important. I think we kind of knew that in back of our minds. That's why we try not to do milling when it's very cold, and obviously we couldn't recreate late fall situation, but still with temperature difference, cooler temperatures, you are making more susceptible your layer below the mill line to be damaged. And then the third thing we learned is that obviously this is all done at one location, different types of machines, as you saw, with two different milling heads and rotational speeds. But obviously before this goes fully into practice, at least the temperature aspect, I think that needs some more testing, and hopefully maybe through NRRA. It doesn't even need to be a research project, but hopefully we can just work with partner agencies to see if they have projects that are either long enough or where there's opportunity to do some milling during colder versus warmer days, it would be really good to back up those outcome of projects so that they can make their way into the specifications. Not sure, Ben, if that provided what you were thinking about or what you had in mind.
No, it just it helps kind of fill everything in too. And thanks for kind of going off script on that.
Yeah.
So I appreciate that.
Yeah.
I guess Deepak has a
Deepak has a
comment.
question.
Yeah.
Thank you. This is Deepak. Can you hear me?
Yes, we
Yes.
can hear you.
Okay, great. Thank you. Hey, I have one quick question regarding temperature, either cold or warm temperature. So when you do testing in lab, did you normalize to the same temperature, your specimen?
Good question. So all of these tests are done at the test temperature of the specimen were all constant, and we do use climate control chambers. So all resilient modulus NITS testing was done at 77 Fahrenheit or 25 degrees Celsius. Temperature here in terms of variable was more to do with the actual pavement temperature when the milling is done. So colder temperatures when the asphalt layer is stiffer, potentially more susceptible to damage versus doing it when things are the pavement temperatures warmer and warmer temperature you are seeing less impact to the material below the mill line.
No, that is good. I'm not talking
Yeah.
about that one. I'm talking
Okay.
about when you take sample, right? Let's say when you are doing in the cold time, okay, taking sample.
Yep.
And you are doing testing, yeah, definitely you will get less strength or stiffness. And we are doing in the higher temperature, it's a asphalt property. So my question is, when you, because even do same testing, but you normalize in different temperature, you put it in condition in different temperature, will that affect or not? That is my question.
It in my opinion, it would have an effect on the outcome, and that's I think if I understood the question correctly, I think what you're saying is temperature at which you are doing the actual coring and sampling of material, and then how it's stored prior to testing. Is that what we are talking about with temperature here?
No, I was looking for even you do coring in the cold weather, but later in reality, your pavement is still will go back to the normal temperature later on.
Correct.
So the strength could be different. To see the effect of milling, I was looking for whether both material were, even though you do operation in different temperature, but when do you testing, did you normalize? That is my question.
No, we did not
okay.
in this study. Yeah, to answer your question, but that's an interesting point and question as well, right? Because as the temperatures change between when you sample and when you test it, how does that impact the properties that you are measuring? And yeah, no, that's a good question. No, in this study we did not do that.
Okay. The reason I asked, I was looking influence of milling operation in the temperature. So how it affects. Otherwise, you are doing with the weather condition. So that is a little different. That was
right. Yeah.
Thank
Here
you.
it's essentially we are doing it with weather condition, essentially taking samples that are taken in earlier in the morning, and the milling actually not samples, but the milling done earlier in the morning when the pavement temperature is cooler versus milling done in afternoon when pavement temperature is warmer. But keep in mind that's still a narrower range. I think we have, I don't remember Kaleigh exactly, we have about 30 Fahrenheit temperature differential, close to that. And I see that Dr. Malik has his hand up, so maybe he wants to add more to this.
Thank you.
Yeah, no problem. Yeah. Rajiv, go ahead, please. Yeah.
There we go.
Yeah, thank you, Ishan. I think that was a good summary of the project. And Deepak, I think that was a relevant question. I just wanted to say a few things about this project. One thing is that theoretically, if you look at the problem, you say that your exerting a very high amount of stress on the pavement. And you can expect stresses going below the milling line that exceed the tensile strength of the mixtures. Theoretically, that is expected. Now, what we see in the field is, as you can see, it's a mixture of results. Sometimes we see the effect, sometimes we don't see the effect. And I'm not counting the results which show abnormally high resilient modulus after testing. Those do not count, actually. Now, what's happening is that if you look at the milling process, you see the teeth are not aligned in the same way. They have a variety of patterns. So there is a randomness in the way the teeth actually strike the pavements. And why is the temperature important? Because as it gets cooler, the material becomes stiffer for asphalt mixes, that is. And as the material gets stiffer, you generate higher and higher stresses in the mixtures. If you have a warm mixture, you can just pluck off the material, so to speak, from the top and not affect the bottom part as much. But if it's a really low temperature, the entire thing gets very stiff. And you create stresses, and obviously you may have hairline cracks, or you may have cracks that are really going to affect your strength. Okay, so again, there's a randomness. So I think when actually you do the milling, makes a huge difference. But your question is very relevant. After we get the cores from the post-mill conditions and we bring them back to the lab, what happens during that process? If it's a higher temperature, do we have a healing of the cracks? Do the cracks, get reduced? We don't know. But as a matter of fact, you can say that if I do the milling under low temperature, definitely you create stresses that are going to affect your lower layers. So I don't know whether that helps to answer your question or makes it more muddy, but I thought I would just share my thoughts.
Thank you. That's good enough. Thank you.
Thank you.
Any other questions or comments for the project team here?
I think Charlie has also asked Ben in the chat if Ben wants to take this opportunity to give an update on the main road construction activities. I like the page. I've been going to the update page that Lauren posted. It's really nice to have week by week update there.
Yeah, I can do that. I don't know if Lauren, if you want to
I think we
include
can
this in
shift to that.
you can edit this if you want.
Yeah.
But again, thanks for the presentation. We'll have more continued discussion on that. I'd like to hear Kat's side of it too a little bit, and the John Garrity's and all the platoonist engineers in each state. I think, what does this all mean for them, and how do we get this implemented? Probably the next thoughts on it.